Hey, what's up guys, my name is the Cherno. Welcome back to my game engine series. So last time we took a look at our whole scene class and how we could integrate the ECS, our entity component system, how we could start using that to actually create entities and add components to them. Check out that video if you haven't already. Today we're going to be continuing on with that, and I specifically want to talk about the concept of an entity class in Hazel. Now, this is probably one of those things that's better to show in the actual code, so I will very professionally using my hotkey transition to this scene where we can also see all of this code. Now, I do want to start off by saying that, okay, 220 zoom. Today's video, again, is going to be a little bit more of an introduction to how we're going to use everything. Our scene class at the moment, if we take a look, has this create entity command or function, which is great, and it returns this entity ID essentially from ent, but obviously this was temporary, and that's what we're gonna work on today to get rid of this temporary registry. We don't want to be returning anything to do with ent into the client, so Hazelnut, Sandbox, all of any game written in Hazel should basically not know anything about ent other than everything that we expose, because instead of going through that API, we obviously want to keep everything consistent with our Hazel API, whilst using ent in the backend. So in other words, what do we actually need from this API? And why are we creating an entity class in the first place? I want to mention that this is not something that you have to do. Again, this is very subjective. This is all up to you and how you actually, what kind of programming style you like using. Now, I'm not completely against object-oriented programming. Like, it seems to be the trend these days that everyone hates on that. The thing is, I don't, and this might be a topic for another video, but I don't really align myself with a coding, not really a convention, but like a paradigm, I guess. I don't really call myself an object-oriented programmer or a, non-object-oriented programmer or like a data-driven programmer, whatever. I don't really care about terminologies. I just write code the way that I like writing code. And in practice, that involves kind of using objects, and object-oriented programming in certain circumstances where I deem it, where I like it essentially, and where I think it will actually help the code. And then on the flip side, if I don't think that objects are necessary, or if I don't think object-oriented programming is a good fit for what I'm trying to do, I'm not going to go down the whole let's create a class for everything and use that. That's silly as well. Now, I'm not the best programmer in the world, contrary to what some of you might think. So you don't have to listen to me. This is just me, saying that, as far as I'm aware, and, just in my general programming, I like doing certain things a certain way. And, there's, who's to say that this is right or wrong? This is just how I roll. And unless it severely impacts people's readability or performance or things like that, I don't really see a problem with it. So, long story short, the way that I like to do this is, and I think the best way to approach this, now that we're a lot more chill with these live stream-esque videos that aren't really planned, I'm having to come up with this stuff on the spot. But it's good because I think it will also translate to me maybe including more information than I otherwise would. Finding it hard to talk right now. So this is our kind of entity situation right now. This is how we're using the API. I always like looking at the usage of an API, or even fabricating some kind of fictional usage of the API, like a future usage of the API, to try and come up with the API in the first place. I think that's a really good way to write code. So in other words, what is the API? What is my dream API for dealing with this? How do I want to be able to create entities? Well, it makes sense that creating an entity should be done on the scene. So this is pretty much a perfect line of code here. The only bad thing here is that this is actually an ent entity. Not the best thing in the world. I would like some kind of Hazel entity here. Even if at this point, entity is just basically using entity as a uint32t like this, which is essentially what it kind of is, right? So we could probably even write code like that or whatever. And you could get away with this because essentially that's what an ent entity actually is. So in other words, this would be fun. Now, the point is though, I don't want to be returning anything from ent. I want this to be a Hazel thing. So again, Hazel entity is probably regardless of whether it's this or something a little bit more deep, like a class or a struct, it's going to be something like that. So that's kind of step one. The other thing is obviously this atrocious situation here where we're not only getting the registry, which we shouldn't even know about because that's an implementation detail. We're also emplacing, which is an ent function, which has a lowercase e, so it doesn't even look like it's part of like Hazel's API, right? This is also not something that we want. So essentially what we want to now be able to do is replace this code with something that we can actually have as part of Hazel's API to add a component to an entity. So how do we add a component to an entity? Now, the simplest case is probably something like add component, but then like we're doing that to the scene. So should add component take in an entity like this, and then like in my opinion, this is becoming a little bit like, this is becoming a little bit verbose. It's becoming a little bit too wordy, I guess. You know, I mean, you're adding a component to the active scene, yes, because everything exists in the scene. But first of all, do we really need to think about this as like, okay, I'm adding components to my scene, which is the registry, rather than to an actual entity? Because we as humans, when we look at an entity in our game engine, when we're looking at it in the actual editor, we expect to click on the entity and then see all of the components belonging to the entity in like the inspector or the properties panel or whatever, right? We don't really want to click on the scene and then get a list of components and then kind of search by entity or whatever. Our brains don't work that way. Even if we look at the actual underlying data structure and the actual implementation, we can see that, yeah, there is just an array of components and entities don't exist. Entities are just used to kind of match different components together, right? Even though that's the implementation detail and that's kind of the programmer way of thinking, maybe if you've written your own ECS or you know how ent works really well and you're kind of in that mindset, you might think like that. But that is not really how I think our brain works when we think of this. Our brain works in the most naive way possible, I think, in this circumstance, which is I have an entity and an entity has a list of components. I want to add a component to an entity. I don't want to add a component to a scene. Even though that might be how it works, that's not how I work, right? And so because of that, I like obviously developing APIs that make a lot of sense to the human in general, because, well, that's what it is. It's an application programming interface. Like, it's something that we use as humans to interface with code, right? That's how I see it. So in other words, that's where this object-oriented thing comes into place. What I would like to do is, instead of doing this, I don't want to do this. I want to actually add a component to this square, essentially, right? That's it, because that's really clear, right? What do I want to do with this entity? Well, I want to add a component to it, or I want to get a component from the square, right? That's how it works. That's how Unity's C# API works, right? I mean, we are kind of the game object ourselves, so we can easily just call get component. It's like kind of like a superclass method and all that stuff. But ultimately, if we did have a C++ API and we retrieved an entity and we actually had an entity like this, which is essentially the same as Unity's game object, then obviously all we do is just call get component on the actual entity. Now, the problem obviously here is that the entity doesn't own the components though. So how does the entity retrieve the components? And that's where my little entity class comes in. And that's what we're going to be doing today. So what I'm going to do is inside scene, I'm going to make a new class called entity. And it's going to be, this is again going to be really simple. So namespace Hazel, class entity. We're going to include scene, which means we can't include entity in scene. That's important to note. Otherwise, we'll end up with a recursive include. We'll deal with entity construction and stuff like that in a minute. We can include ent, and I will have to include ent actually. So include ent, what even is it? Ent.hpp? I don't know. What did we do in scene? Scene. We didn't ent.hpp. Yep, okay. So what this is going to end up being, this entity, is it's going to be a very thin, kind of easily constructible, destructible stack object, essentially, that is going to, all it's going to do is provide a convenient set of functions to ent, right? So in other words, what I should be able to do is I need two pieces of the puzzle here. I need the ID of my entity, and I need the scene that is the context of the entity. Where does the entity live in, right? So in other words, where is that registry? If I have those two pieces of information, I can do anything I want, right? And this is going to function as a wrapper for that. So the way that I like to do this is add in those, oops, there's that Russian again, add in those pieces of information. So we have entity being our like entity handle, I'll say. And then also we need some kind of scene. Now, I don't want to take a ref to a scene because I don't want the scene to, I don't want the entity to somehow own the scene, right? So if I did this and I just had my scene here as my context, then since this is like a strong reference to a scene object, if I still have one of these entities floating around, which again is just it's not even like something that you store, right? It's just like it's just an interface really into like all of the entity functions we want. If that's the case, then my scene's not gonna get released from memory. What I ultimately want here is basically a weak ref, right? I want to have a weak ref of a scene, which is basically just a way for us to have a scene pointer, and then we can just, but it's not gonna take any ownership. So in other words, we can check before we use it, is it valid? Is it pointing to a valid object, or has scene been deleted? And if it hasn't been deleted, then we can go through with this. Again, that's probably what you want to do in the optimal case. I'll leave that up to you if you want to do something like that in your engine, if you're following along. At the moment, we're in no remote circumstance to be using weak refs, especially, well, because the reason I really don't want to do this is because we're still dealing with shared pointers in C++ classes, whereas in the future we're going to be switching to an intrusive reference counting system that we're going to write. And since we're going to write that, we're going to have to write our own kind of version of the weak ref. And anyway, to keep matters simple, I'm just going to have a raw pointer to a scene, okay? So this is going to have a scene raw pointer, and it's going to have an entity handle. That is it. Because this is relatively lightweight, this should be 12 bytes of memory on a 64-bit build like this. It's fine to copy this. It's fine to construct it and destruct it at will. You can do whatever you want with this. This is not something that you need to be passing by const reference everywhere. It's not something that you want to retain. You can easily construct it in a scope, use it for whatever you want, and then discard it. That is how this object is meant to be used, and you'll probably see that throughout this. Because really, as you'll see in a minute, it's just a way for us to call certain functions and make our code look cleaner. That's it. We basically push in all the data we want, basically the parameters to these functions. We push them into an object like this, and then whatever functions we call, since these things, I'm pointing at my screen for some reason, since these things are actually like part of this object, they're members, they're available to the functions that we write in this class, and we can take advantage of that, and that's what we're doing. So to basically to show you what I mean, if we say template type name t, this would be like something like has component, right? Has component. So we're checking to see if this entity has a component. Well, what do? We'll call scene, then we get into the registry, which we're going to change in a minute because really we want this. And I'm going to make entity a friend class of scenes so that we have access to that. And then I think we just do has t and then m entity handle, right? And that's what we return. If we hop over to scene really quickly, and I just down the bottom here, I'll say friend class entity, just so that we have access to this. That's what we can do to see if this entity does in fact have this, whatever the component we ask it, does it have this component, right? So let's quickly just add in some extra stuff here. So entity, I'll say entity handle, and then scene pointer scene. We will probably, okay, I'll make, just to keep, no, I don't know what I should do. Okay, I will make a CPP file for this. I didn't really want to just because I don't feel it's necessary, but on the flip side, I do want to keep that header file as easy to read as possible. So if we have even something as simple as this constructor, and obviously a shallow copy constructor is all we need for copying. And yeah, you can obviously, this class is intended to be copied whenever we need. Scene. Oh, right. I was wondering why that wasn't auto-completing because I forgot the namespace for the class. All right. So, yeah. So that's it. And then if we kind of, and I'll just add in the basic stuff like const entity other, This is the copy constructor, just to explicitly say that we actually have that copy constructor there and that we're intending for it to be used. Again, this is not something that you need to add, but I like adding it just as like an extra kind of tip to the programmer. But C++ will provide it in this case, so it is kind of redundant. So do as you will. Anyway, so now that we've got this, the idea is that first of all, create entity is supposed to be returning an entity, right? But even if it doesn't, even if we kind of wind up with a situation where somehow we've got just the entity ID, but we also know what scene it's part of, guess what? We can easily just say entity, and this is inside Hazel. We can say, actually, let me quickly include entity here. Okay, we can just say entity, you know, square or whatever, which I'll call square entity, is just equal to square, which is the ent ID, and then active scene, which I think is a shared pointer, so we'll do get. And that's it, right? It's an incomplete type. Yeah, I don't think this actually includes it. Editor layer includes, oh, it does include hazel.h. So why is that an incomplete? What's incomplete about this? That should be very complete. That's a bit odd. Okay, it's working now. Never mind. Visual Studio. So yeah, so now we have this, right? And then we can just ask it, hey, do you have, as component, do you have a transform component? And now, do you see how nice that API is? Isn't this just really nice? I think it's really nice. Let me know what you think, but I think it's really nice. Now, obviously constructing it all the time, and this is the beauty of it, right? If you're in a situation where you just have an ent entity ID, right? And you have the active scene, you can easily just in that function scope or wherever you are, just quickly construct this. Hazel Dev does this all the time, okay? It's basically built on this system. If it wasn't like anything that has to do with like, hey, we have an entity, we have a scene, I want to start using the entity API, we basically go through this because it's really nice to read the code like this, and it just makes everything a lot easier. So that's how all of that works, okay? Now, obviously, create entity still returns an entity, which is wrong. I want it to return an entity. So what we'll do here is, I think we will, okay, so this should return an entity. We'll just add in entity as a forward declaration here. That should be fine. And then this is just going to return registry create, which creates that new ent ID for us, and then this, right? And then that is how we're going to construct entity, and we obviously have to include entity in our CPP file here. All right, there we go. So registry goes away now, and then we have to add a whole bunch of functions. And so we'll start with, I guess, the add component function. So how does the add component function works? Now, we don't want to necessarily lose all of the nice API that ent gives us. A lot of it, we simply want to take and kind of forward all of our arguments across to ent, basically. And so a particularly nice case that ent actually has is this, as you can see. If we're constructing this component, we don't just have to basically say that, hey, we want to in place this component. We can actually provide it with the constructor arguments to construct that component kind of in place. The same way that we would do it with a vector when we want to, like, essentially when we use the in place API versus the pushback API, we're able to actually forward our constructor arguments so that it gets constructed in place rather than in this stack frame and then copied. So it's kind of like we're just saying, hey, here are the arguments I want you to use to construct this component in this case, rather than having to make the component ourselves and then give it to our entity registry. So to make that happen, we basically need to write a templated function that just forwards our arguments across to, that perfectly forwards our arguments across into entland. So to do that, we'll have to add a variadic template here that is basically going to work for any number of arguments, and then we're going to take those arguments and just forward them to ent because we definitely don't want to deal with them here. So t reference add component, because of course we still want to return the component by reference, just like ent does, and this is essentially going to return scene, registry, and then in place, along with, as you can see, the component type, and then all of the arguments. But we don't need to provide the arguments in the template arguments. We can just write them here where we have scd forward, what do we call it, args, and then args ... have to remember the syntax for this. So essentially all we're doing here is we're saying that, and we need to actually provide these arguments like this. And this is a little bit confusing. Probably not going to discuss it too much because it's more of a C++ thing. But essentially, this is a variadic template. These are all of our variables that we're passing in, and then we're saying that like don't unpack them here. Let's just forward them all the way to ent, because ent, as you can see, the in place also takes in the same thing, right? So this is just a way for us to say don't unpack all this variable number of arguments and handle them here, which we could do. We're saying that just take them and just pass them along. So that's what's happening here. So we're emplacing entity handle with a variable number of arguments, which will make up the constructor arguments. And then that will, of course, return a reference to whatever type we pass in here. And that is what we're returning. Pretty simple. Now, get component is also another simple one. Type name T reference get component. This is just going to be scene registry get, and then T, and then entity handle. All right, really easy. Now you can see that this code is quite verbose though. That's the thing. Like, I mean, we wouldn't be forwarding arguments if we weren't in here, but in general, like, you know, scene registry, blah, blah, blah. Whereas we're able to just call square entity has component. So that's another nice benefit, that it just kind of makes everything a lot more simple. Now with get component, for example, and potentially with add component, you probably want to add some asserts here, especially because they're just in debug, just to make sure that we don't have that component. So you could easily just run has component, let's say, because otherwise it's going to assert within ent, and that might be harder to debug because ent is not that easy to read. So we want to keep this as easy as possible. So we can just say has component T, right? Or specifically not has component T, right? So this is just gonna, and we can say entity already has component. That's correct. All right, and then same with get component. We want to make sure that we actually do have the component. And if not, we can say entity does not have component. Okay, so these are just some ways for us, and I'll just get rid of these spaces. These are just some ways for us to just, you know, be a little bit more in control with what's going on and make sure that we're not asserting inside ent, because if we are asserting inside ent, it might be a little bit more, difficult to debug. Okay, what else do we need? Oh, remove components, an important one. I'm just looking at Hazel Dev code for reference, by the way. So if you see me glancing over here, that's what I'm doing, because I'm not going to pretend to remember everything that I wrote over like weeks. So remove component obviously is very simple, and we'll simply call scene registry remove T from entity handle. And again, we'll just assert that that we do have that component that we're trying to remove. Okay, I think that's it. I mean, if I look at other stuff, like there's a lot more in this class inside Hazel Dev. There's a lot more. It's not needed at this point, probably. There's some implicit cast operators going on. There's some convenience operators for like retrieving the transform. So instead of calling get component transform, you can just call entity.transform. That's another really important thing, because it's every entity should have a transform. There's also like UUID stuff, which we should probably talk about that soon, shouldn't we? Yeah, we're going to need to have some kind of like globally unique or universally unique identifier system as well for our engine, and that's going to be a big topic to talk about as well, because that's a very important system as well for a game engine. Anyway, let's not get too ahead of ourselves. So now that we have this, right, so this is now a Hazel entity, which means we don't even need this. Now we should just be able to say like square has component transform. Let's make this a little bit better though. Let's actually, and again, you know, we could, you know, say registry create, get that kind of entity ID, and then say registry and place the component and do all of that stuff, but we're not going to do any of that, because instead we're going to take this and we're going to say entity, you know, entity equals registry create. That's what we're going to return. But then we're also going to say entity.add component transform. All right, transform component. And that way, now all of our entities that we ever create we'll have a transform component as long as we create them using this API. Same with like a tag component. So let's add that right now. We'll add a tag component. Tag components. Tag components. Obviously it doesn't exist yet. So now we'll go to components and we will add, I'll make it the first thing here, tag components. And this is obviously going to be an std string tag. You might want to make this maybe not an std string. So tag component will say default, and then we'll make sure that it's like copyable and everything. Well, copyable it will be, but we'll make sure that it is constructible with a string like this as well. And the default constructor is going to be, we could make the default constructor like unknown. I don't know. We'll just leave it blank. Tag. All right. So now every entity has a tag component. It doesn't necessarily have to have a tag component. Here's what we'll do. We'll go to scene. We will actually make every entity have a tag component because I think that's going to be useful. Const std string name. So when we create an entity, we specify a name. However, I'll make it so that we can have an empty name here. And if we maybe I'll write it like this actually. If we have this here, then we can just check to see. So with the tag, right, we'll add it. So this is auto tag. And we'll say if name is empty, then tag.tag equals, what should we have? I don't even know. I can just call it entity or unnamed entity or empty entity. I don't know. We'll just call it entity. Otherwise, I guess we'll write this as like one of these ternary operators. So if the name is empty, it will be this. Otherwise, obviously, we'll assign it to name. Okay, so now we have an entity with a tag and a transform. And no matter what, it will be that. So we can now call this our square, right? And then the idea is that we don't need this. We don't need to add transform anymore. All we do here now for this green square that we've got is we don't place anything. We add a sprite renderer component. You can see our arguments still get forwarded to end and everything still kind of works as normal, which is great. We can, again, with square entity, so why are we doing that? Oh, just so we can control it. Okay, great. So that's kind of good as well. That's a good example. So if we go back here, instead of this being an entity, this is now a Hazel entity, right? Which is just an entity. And then down here, instead of doing all this stuff, we just say square entity get component, sprite render component dot color, right? And that's our color that we modify. Let's hit F5, see if all of that compiles and actually works. No default constructor for entity. And we need, yeah, okay. Yep, that's also important. So we should have a default constructor for entity. I'll add that in, and I'll also just say that, I don't know if we can properly initialize this. I guess we can. No. Entity, can we, the thing is it's an entity ID type. Enum class entity is an ID type. How do I initialize that with a value properly? Because I guess that. I just want to, I need to make sure that these are set like this. The reason is it's also valid to have an empty entity, like an entity that actually doesn't have it, doesn't exist. And what I'll actually do is I'll say operator, I guess this will be a, bool, no, it's operator bool, isn't it? Const return entity handle doesn't equal 0. Okay, this is just a way for us to check to see if the entity is valid or not, right? So now that we have that default constructor, everything will compile. But the cool thing is at this point, we could, for example, inside our renderer or wherever we use this, check to see if square entity is a thing just by saying if square entity. And if square entity is set to something, then it's going to work, right? And we can test that out by also just leaving that in there, even though obviously we know that it's going to exist at this point in time. All right, sprite render component no overloaded function takes 2 arguments. Okay. Sprite render component. No overloaded function takes 2 arguments. What's going on here? And that's coming from... from our add component function. What? Don't we have 1 argument? Sprite, that's a sprite render component, right? Components. That's definitely got a constructor that takes in a vec4. So did I do this wrong? Oh, I've still got square in here. So obviously it's trying to, yeah. I've still got square in there because that was from the in-place function that required the entity. Okay. False alarm, everything's great. All right, there we go. There's our green square. Obviously it's valid because we're seeing the square color here and we can still change the square. Everything still works like it did before, which is great. Let's do one final thing. And when we display this, let's also say I am GUI text, and we will say, and let's be all cool. Let's add a separator so that we know this is all kind of grouped together for our square entity. And then we'll, and I guess I can just do the separator inside here. And we'll say text, let's see, %s here for a string, and we'll set this to be square entity get component tag component.tag. Okay? And I don't know if ImGUI is happy with, we might need to give it a C string here. Why is this so upset? Okay, that's a little bit odd, but fair enough. Auto tag equals that tag.cstring. All right, because we had a temporary there, and you don't want to be taking pointers to temporaries like that. But also, something's still wrong here. What's going on? What am I doing wrong? That's a string, right? Error type. So that just didn't work at all. Get component. Oh. I don't know why you guys watch my videos. Honestly, clearly I need to learn how to actually write code. Okay, so there's square, and you can see it's called square, right? It's got the name square. Now, obviously in this case, I mean, it seems silly, but I could call this like green square or something like that. And you can see I'm just giving the entity a name by setting its tag component, essentially. And then we obviously see that over here, green square, and we can change the square color to anything we want. All right, so that is the entity class. Really kind of easy. Next time I want to talk about camera entities. Let me quickly switch over, and this is very unprofessional, but anyway, next time we're going to be talking about cameras and how we're going to set up the camera to function in the entity component system. I think that'll be a fun little episode. Let me know what you guys think of this entity API. I really like it. I think that it's really, it makes the code look really clean, and that's my kind of preferred way of doing everything to do with kind of entities and components, as far as like how I want to use them as a game developer, not a game engine developer. And also how I would expect them to appear in the scripting language. So I think that's why it's good that it is the way that it is. Anyway, thank you guys for watching. If you did enjoy the video, please don't forget to hit the like button. Also help support this series on patreon.com/thecherno. Thank you to everyone for helping to support the series. Don't forget that you will get access to live streams of me developing Hazel Dev, and also the Hazel Dev code if you help support me on Patreon. Thank you all for watching. I'll see you next time. Goodbye.